Hello everyone. So today I'm gonna explain all of you about trigonometric identities. So I've seen many students facing problem in this topic. So to understand this topic, we need to first understand about what is relation of the ratios. Means we have to know the trigonometric ratios properly first. So when I'm talking about relation of ratios, I should know that Sin theta can be written as 1 by cosec theta. Then that means the opposite is also right, vice versa. Cosec theta can also be written as 1 by sin theta. Number 3, cos theta can also be written as 1 by sec theta, and sec theta can also be written as 1 by cos theta. Similarly, tan theta can be written as sin theta by cos theta, and cot theta can also be written as cos theta by sin theta. Actually, we can write tan theta even this way, which is 1 by cot theta, and cot theta can be written as 1 by tan theta. So today the sum that we are going to see, there we will be using this point most of the time, this one most of the time, means whenever we see cosec theta we will convert it to 1 by sin theta. Whenever we see sec theta we convert it to 1 by cos theta. Whenever we see tan theta in the sum, we will convert it to sin theta by cos theta. Whenever we see cot theta, we'll convert it to cos by sin theta. Now what is the reason is, it will help us to get the solution quickly. So wherever we see cosec theta, we will convert it to 1 by sin theta in the next step. Wherever we see sec theta, we will convert it to 1 by cos. Wherever we see tan theta, we will convert it to sin by cos. And wherever we see cot theta, we will convert it to cos by sin. So this is what we have to remember. Now, if you ask me, if we convert, if sin theta is there and if we convert to 1 by cosec, will something happen? Then actually nothing will happen, but we might get stuck or we might not reach to the answer. So that is the only thing. So these are like hints. Wherever we see cosec theta, we have to convert to 1 by sin, sec to 1 by cos, cot to cos by sin, and tan to sin by cos. So we need to first remember these four things before we start today. So you can write it down, and when we are doing trigonometric identities, it's better we write it down, the trigonometric ratios, relation of the ratios, and the identities. So these are the relation of ratios. So as I said, as I mentioned earlier, these 4 points we need to remember. And the other thing that we have to remember is the identities. So I will show you quickly the identities. So there are three identities that we have to remember. And that also how we will know is it's by writing only. So it's better we write it down, then we will be able to remember the identities. So the first identity is, or the formula, you can say, we will not be going to the derivation and all those stuffs. The first one is sine square theta plus cos square theta. It should be 1. So from here we get one more point, and that is sine square theta is equals to 1 minus cos square theta, and one more, which is cos square theta is equals to 1 minus sine square theta. So whenever we have square, we will not think about the relation of the ratios which I had given just now, a while ago. So whenever we have square, we'll think about the identities. Like let's say we were solving a sum and we got stuck here. Let's say a situation came that we got stuck here. Then in the next step, we can say it is 1 because sine square theta plus cos square theta is 1. Similarly, while solving the sum, let's say we got stuck here, and the next step we can write sine square theta as 1 minus cos square theta, because whenever square is there, then only we can think about the identities. But yes, there is one thing that we can do here is, if I get stuck while solving sum here, we can always use the relation of the ratios and write 1 by cosec square theta if nothing is working out. So we will see that as well. So this is the first point, which will give rise to 3 more points. Then let's see the other one, other identity. Second one is sec square theta minus tan square theta is equals to 1. So from here we will get sec square theta is equals to 1 plus tan square theta, and we will get one more. We are just using basic mathematics. We are just transposing tan square that side and it becomes plus. Same way we are transposing cos square this side becomes minus. So those are the basic of transposing we have done here. Next that we can get here is tan square theta is equals to 1 comes this side, it becomes sec square theta minus 1. And lastly, the third identity is cosec square theta minus cot square theta is always 1. And from here again we can get two more points. One is cosec square theta is equals to 1 plus cot square theta, and cot square theta is equals to cosec square theta minus 1. So when we will be using this identities is whenever we have square with the trigonometric ratios. Like let's say we have tan square theta, then we have the option of using this as well. Or we have the option of doing it like this as well. Tan square theta is sine square theta by cos square theta. So we will see now. So we need to first remember all these identities properly. So we should know the relation of the ratios and the identities properly. Then only we will be able to solve sums from this exercise. Because I have seen many students complaining that they were not able to understand the sums here. They were not able to solve the sums here. So let's see few sums. Let's see how many we can do. Let's take first the basic one where we are just using the relation of the ratios, means the point which I gave you earlier. Like whenever cosec theta is there, we will convert it to sine theta. Whenever sec theta is there, we will convert it to 1 by cos theta. Whenever tan theta is there, we will convert it to sine theta by cos theta. So using that point, let's try to do one sum, and one sum I'll show you using identities. Okay, so let's say, so let's take this sum. 1 plus cos A divided by sin A plus sin A divided by 1 plus cos A is equals to. So we need to know the hint here, otherwise we will be getting stuck. And as I mentioned earlier, whenever cos is there, sine is there, don't convert cos to 1 by sec. We know we can write cos as 1 by sec, but while solving sum, it is advisable not to convert cos to sec. Had it been sec, then yes, our first step will be converting sec to 1 by cos. So that is the hint. Whenever cos is there, we will not change to 1 by sec, even though it is right. But whenever sec is there, we will convert it to 1 by cos. That will be the first step. Similarly, whenever sine is there, we know it can be written as 1 by cosec. but we will not do this point. It will, we can get stuck in the question. So rather, if we have cosec a, we can write 1 by sine a as the first step. So this point which we is very very important. So whenever you have cosec, change to 1 by sine. Whenever you have sec, change to 1 by cos. Whenever you have cos, no need to change. Whenever we have sine, no need to change. And whenever we have square like this, then we'll think about the identity. Sine square is 1 minus cos square. So the, so this condition is not arising only because there is no square here, so we can't think about the identities at the moment. So we can think only about this relation of the ratios. And as I said just now, whenever we have cos, we can't change to 1 by sec, and whenever we have sine, we can't change to 1 by cos, and we cannot use the identity also. So what is the step left here? And the only step left here is, if you see there, it looks like a fraction. It looks like 3 by 4 plus 4 by 3 if you see closely. So since I can't change sine to 1 by cosec, can't change cos to 1 by sec, can't change cos to 1 by sec and sine to 1 by cosec. So the only step left is now to do the addition of these two fractions. So whenever we have fraction, what do? We take the LCM of the denominator, and if 4 doesn't divide 3 and 3 doesn't divide 4, that means if the common factor is 1, or if the HCF of these two numbers is 1, then their LCM will be the product. That means 4 into 3 is 12. Same way, sine will not divide 1 plus cos A, and 1 plus cos A will not divide sine. So the LCM of these two will be the product of these two. So we have to understand why we are taking LCM. We are taking LCM because we cannot use this point and we cannot use the identity point. So the only thing that is left out is whenever we have a fraction, taking LCM. That is the reason we are doing LCM here. Now next, so once we got the LCM, what is the LCM rule? So we write the numerator as it is, then we write down here 3. Now how we came to know 3 came here? We have to divide the LCM by 4. So when we divide 12 by 4, we get 3. Or we can say that 3 by 4 was there, and because the LCM is 12, so I need to multiply the denominator by 3, and since I multiply the denominator by 3, I have to multiply the numerator also by 3. So this is also one condition. Let's get back to our sum. So the denominator is sine 1 plus cos A, means the LCM is this. So I have to divide the LCM by the denominator. But first I will write down what is there in the numerator. So this is there in my numerator. Into, so this LCM, which is sine A 1 plus cos A, I have to divide this LCM by the denominator, which is sine A. So sine A gets cancelled. I'm left with 1 plus cos A. So that's how I got 1 plus cos A here. Plus, we write down the numerator as it is, sine A. You can take the help of this number. We write the 4 as it is. Then what number will come here? 4. How we came to know? Because we divide the LCM by 3. So 3 4s are 12. In the same way, how we will know what will come here? We will divide this LCM by the denominator here. So if I divide the LCM by the denominator, we will be getting sine A. So you need to copy down these things, then only you'll be able to understand. If you're just looking, then it won't be helping you. So I would suggest it's better you write it down. Then the next thing that will happen here is, we know that when two things are multiplied two times, then the answer is square of that thing. So A square. Same way, when two same things are multiplied two times, we can write 1 plus cos A whole thing square, plus sin A into sin A will give me sin square A, because it's just like A into A, so hence it will be A square. And in the denominator, no need to do anything. You can just leave it as it is. Okay. So now what will happen is, we have got 1 plus cos a whole thing square in the numerator plus sine square, and in the denominator we have sine a bracket 1 plus cos a. So the only step possible now after this is opening of this bracket. And how can we open a bracket when it is like this? There is only one way, and that is using again one algebraic identity, a square plus 2ab plus b square. This is the only way to open a bracket like this, or a binomial which is having square. So this time my a is 1, so 1 square plus 2 into a into b plus b square, plus that sine square was already there. So this is my a square plus 2ab plus b square. I'm not writing this step, actually this should be the step, b square. Then the next step will be cos square a. We don't write square on top of the a because a is the angle. We write square on top of the ratio, which is cos. Okay, divided by, we have sine a 1 plus cos a. So this will be 1 plus 2 into cos a is cos a, because 1 square is 1, and plus, and if we see this one closely, they are having square. This trigonometric ratios are having square, and as I said earlier, whenever we have square, we think about the identities. And this one looks like sine square a plus cos square a. And when we are having sine square a plus cos square a, we know that this is equal to 1. That means in place of this, we can remove this one and write 1 there. So here we have taken the help of identity. So that's how you should know when to use or when to take the help of identity. So we got this. Then the next step will be, after this, is basic algebra. Like in the numerator, we can add the numbers, means this one and this one will give me 2 plus 2 cos a, and denominator will remain as it is, sine a 1 plus cos a. After this, we cannot add anything in the numerator, because 2 plus 2 cos a is just like unlike terms. If we see algebra, if we try to bring algebra here, 2 plus 2x, the next step is we can't do anything here, we can't add. So in algebra, when we cannot add, we try to look for common if we have to do the next step. Means whenever we cannot add or subtract in algebra, the only step that is possible after that is we look for common. Is there something same in this term and this term? And if we see here closely, we can see that 2 is same here, 2 is here, 2 is here in both the terms. So that's why I can take out 2, and 1 will be left out in the first term, and x will be left out in the second term. So 2 into 1 is 2, and 2 into x is 2x. So I'll use this same logic here. So since we cannot add this 2, because the concept of like terms, 2 and 2 cos a we cannot add, so I will take 2 common. I will be left out with 1 plus cos a. Denominator I won't be changing, sine a 1 plus cos a. And if we see properly, 1 plus cos a and 1 plus cos a are exactly two same things. And we have learned that if two same things are in numerator and denominator, then the answer is 1. They cancel up to 1, because 2 ones are 2, 2 ones are 2. So 1 by 1 is 1 only. Same way, 1 plus cos a divided by 1 plus cos a is 1 by 1, which is 1. So we are left with 2 by sine a. After cancellation, we are left with 2 by sine a, 2 by sine a. So that means it is 2 into 1 by sine a, which is 2, and 1 by sine a is what, according to relation of the ratios. 1 by sine A is cosec A. So that's how we got equal to RHS. Hence, we have shown LHS equals to RHS. So if you have seen how we have done the sum, we did not convert cos A to 1 by sec. We did not convert sine to 1 by cosec. We know we can convert cos to 1 by sec, sine to 1 by cosec. We know that that point is there. But because of the hint says that whenever cos is there, never convert cos to 1 by sec. And whenever sine is there, never convert sine to 1 by cosec. So we did not convert this cos and sine. Then what we did, we since we cannot convert, the only thing that was possible here was taking LCM. So we have just taken LCM and then we've just used the basic of algebra, and we have used an algebraic identity. And finally, at the last step, we have used relation of the ratios, and here we have used trigonometric identity points. So please go through this sum. I'll come up with another video where I'll be showing another sum related with this topic. Thank you, everyone.